Hello class, welcome to Module 4. This is a helpful video that should help you work on your Lab 4 and your Assignment 4. As you know that Lab 4 is a scaffolding for your Assignment 4, and Assignment 4 mirrors all of the topics that you have learned and practiced in the lab. So this is again an example that is familiar to you, the point class, and the topics that I will go over which relate to this week's module are using static counts. The other thing is to create a vector of objects, and also exception handling. Iterating through the vector is something that you have done before, so that is not new, but we will go over that as well. So here goes. The other feature that I'd like you to keep an eye open for is see how I'm using multiple header files. This is something that is very typical when you write large pieces of software, and I will point this out to you as we go about why we need two headers and what's going on. So please do not be confused with this main.cpp. My IDE would like every main program to be called main. So in your programs, this might be called point main.cpp, right? And as you know, nomenclature is very important because we are going to construct makefiles and all of that. So here is a program in which you are asked to create a vector of points. Points is the same good old, I'm going to open the point header file here, is a point is a class which is used as a template to create point objects. And what is a point object? It just contains the coordinates at which the point is located, which is integer x and y. And we have a default constructor and a regular constructor. We have the getters, and we do not have in this example we do not have setters because we're not using them. The features or the behavior of points are you can get the distance from one point to the other. This is something that you practiced in your Lab 3. So one object can, looking at another object, can actually gauge and calculate the distance, right? And also a couple of other, and of course our famous toString method, right? So this is a familiar example to you, and we are going to build on top of that. So what are we doing here? What we're doing here is we are creating a vector of points. Right? How are we creating this vector? We are creating this vector by inputting the data. This is probably something that we are doing for the first time, inputting data from a file, right? Now note that even though I have not done it here, but this is the exact same procedure that you will follow if you were to create a constructor that is given a file name and it opens the file and creates a vector of objects. This is something that is either here in your Lab 4 or is definitely coming in the future assignment. So it's definitely worth noting how to handle this. So here we go. I've got a method called input data, and I'm passing to this input data the vector that I have created here, which is empty currently, and also I'm passing the file name. As you can see, I've got a data file which is very simple. It can be used to create a vector of 4 point objects, and here are the x's and y's of these objects, right? So let's go back here. So this is the file name that's passed. Now the question is, where is this input data function located? Currently in this particular program, in this particular application, this is not something that your class is doing. This is just a method that your main program is doing. So the question is, where is this input data defined? Now I have chosen to demonstrate in this video how you can, in addition to the header file, which is right here for the point class, which is related to point.cpp, and we could rename this as pointfunctions.cpp also, but I've chosen not to do that, so please do not be confused. So this point header relates to this point.cpp class, and here, because functions is something, the word functions is something that's very typical for static functions, right? And this is a class file which contains the functions that are defined in the point header file. So going back to where is this input data defined, as you can see, I've got a functions file. This functions file has nothing to do with the class file. These are functions that I'm using in my main program, and I've chosen to tuck them away into a separate functions file, right? So the input data here, this method, it takes in a vector. Know that vector always works through, you need to specify that it is passed by address, unlike vectors where unlike arrays where it's done automatically, and I've also passed the file name. Now, so what am I doing here? What I'm doing here is I am creating a infile variable, a variable called infile, and I am going to try to open this file. If I'm able to successfully open the file, then I should proceed with populating my vector. But if I choose not to open, if the file doesn't open or there's an error, then I should exit this application, right? So here is where this is the kind of stuff that you're going to be building in your lab and assignments. Very, very basic exception handling. How to do this exception handling is you enclose this in a try catch statement. As you can see, if the file is either corrupted, it's not there, but you failed to open it, then you throw an exception, right? So this is one syntax, very simple syntax for exception handling, and we will go into how to do it in the object-oriented way a little later. So you can see throw string file open error. When the program reaches this point, the execution jumps to the catch. It does not go in here, right? So the program, if the file does not open, then it displays file open error and jumps here where this message that was thrown gets printed. I can add one more thing here and I can say, you know what, don't do anything else, just exit out of the program and be done with it, right? So, but if the file opens successfully, look here, there's another feature. You may have done this in 360, but just as a review, what I'm going to do is while there is a line in the file, while not end of file, get line, get each of this as one line at a time. So each line contains, the first line contains 2 space 3, second line contains 0 0 and so on, right? So get the line, and then here you see I'm using the Istringstream operator. The Istringstream operator is great for doing data type conversion. Remember how you use the toString operator to convert? Well, if you use the Istringstream, we can automatically do data type conversion, right? So here we go. I am putting this input stream into the iStream object and then reading from the iStream object into X and Y, and it will automatically do the type conversion from that string into an integer for me, and that's a huge advantage. So this is an additional piece of learning, and you can see how we are refining using C++ features to do away with all the difficulties that we had in previous assignments. Now what I do here is I use that X and Y to create a point and push it back into the vector. So I keep looping, and now at the end of this, I have created a vector with 4 points, right? This is my input data. Now what is this business point another header.h? You see, I am also creating not just a header file for the class, but I'm also creating a header file for all the functions, the global functions that I'm using. So you see this one contains only one method, the one method that I'm tucking away into my functions file. But this function refers to the point class. Therefore, I need to include point header.h here, right? Because what I'm saying is I'm going to create objects of point type, and therefore I need to include that header file as well. So please, I will post this solution, and please make sure that you make a careful note of where I'm including which header file and so on. And this is also part of the learning that we are expected to do. The other thing that I wanted to point out was, as you can see, I have introduced here in the point header file a static global variable. In object-oriented programming, doing global stuff is not great, but there are exceptions where here you've got the static count variable which keeps track of how many objects were created. There's no reasonable way to do that except by having the static, which is like a shared memory, right, which keeps track of how many objects were created. Now the question is, well, how are we going to increment static? And the answer to that is, well, where is the point object constructed? It's constructed in the constructor. So how about every time a constructor is called, we increment count, and this will increment the count for us, right? Now, the question arises, where was count initialized? Well, it turns out that count needs to be initialized right here, where you define all the programs. Where did it go? Point.cpp. You see where you defined all the functions? Here's where I'm also using the static scope resolution operator to initialize my static count variable, right? You can write, of course, this is just an example program. You can write getters and setters for count and so on. I've tried to avoid that in this example program by making my static count public. It's not such a great idea to do it. I would expect you, if you were used to use global static, to keep it private and then to write get count and set count. For example, set count might not be necessary, but definitely get count, right? Now, one of the big deal things about this exercise is that count keeps a track of how many objects were created. So you create an object and push it into the vector. In this example, you will see that when we access the count, then it will give us the number of elements that were pushed onto the vector. And if you do vector.size, then that also will give you, as you can see here, number of static points created is v0.count. We're actually calling the count method of an object inside the vector. Right here, we are using the size method, which is given to us, right, to get the size of the vector. In this example, both are going to be the same, but I'm going to leave you to think what happens when you delete elements in the vector or erase elements in the vector, right? Are these going to be in sync or are they not going to be in sync, right? So I'm going to run this program here, and as you can see, what I'm doing here is inputting the data, the vector v. It is now populated with all of those points, and I'm able to use the iterator to, I didn't actually need to do this. I could have done auto iter equal to v.begin, going all the way to v.end and iter plus plus, and then print out the point object using toString. So here I'm actually accessing that object, and I'm printing out the number of points created. Right? So there are a lot of files here. I'm going to ask you to look very closely to see how I'm including point another header, because point another header actually turns out includes point header, and you don't want to include it multiple times. And also see how I'm including stream, because I'm going to be using the Istringstream object, not the Ostringstream, but the Istringstream object, which is really useful for me to take in a line and then to be able to do the automatic data type conversion, which is what I'm doing when I read stuff from the file, right, and read integers into my points, right? So so that is an overview of the concepts and practice that we are going to be doing in this module. To go over it one more time: Istringstream, vectors, static int, and using multiple headers, right, and using iterators. So good luck with your lab, and